I think we have just covered the first seven chapters, right, up till now. In the previous lecture, that the lecture which I have taken in the Sunday, right? In that I have just tell all the things related to the seventh chapter. That is our that is nothing but the univariate continuous probability distribution. That means in the fifth and sixth chapter, we have discussed up till now. It is about the discrete probability distribution, and the sixth chapter was about the univariate probability distribution. Now, today in the seventh chapter, we have to discuss some standard probability distributions. But these are my discrete distributions. Okay, so we have to discuss today some standard discrete probability distributions. Okay, standard discrete probability distributions. So what are that distributions? So my first discrete standard discrete distribution in this particular chapter is uniform distribution. Okay, we have to discuss about uniform distribution. Uniform distribution. Okay, so let's start with this. So what is the definition of the uniform distribution? Okay, understand the definition. Suppose I have a variable, one particular variable I have, a random variable I have, right? It is capital X. And which is, so what is the definition? A discrete random variable X, okay, which assumes the non-negative value. Okay, it is a non-negative variable. So this non-negative variable is said to follow uniform distribution with parameter n. Is said to follow uniform distribution with parameter n having the having values. Now since this is non-negative, okay, it is a non-negative distribution, the values will be what? 0, 1, 2 up to n. Okay, these are the non-negative values, right? So a discrete random variable x having the non-negative values, right? So is said to follow uniform distribution with parameter n if if its PMF. PMF means what? Probability mass function. Okay, probability mass function. If its PMF is given by, if its PMF is given by, we have already discussed, right? What is the difference between PMF and PDF, right? PMF means what? PMF, PMF means anyone? Difference, tell me, difference between PMF and PDF. Yes, anyone? My screen is visible, right? Hello. Okay. Yeah, can anyone? Yes, and PDF is probability. No, it is probability density function. Okay. PDF means probability density function, and PMF means probability mass function. Probability mass function we are taking for the discrete random variable. Understand? The seventh chapter is all about the discrete random variable. That means not random variable. Here we are just studying that distribution. What are some distribution in the discrete distributions? Okay, or the discrete random variable. Okay, इस सेमिस्टर में फर्स्ट सेमिस्टर में आपको सिर्फ डिस्क्रीट प्रोबेबिलिटी डिस्ट्रीब्यूशन स्टडी करना है. जब सेकंड सेमिस्टर में जाओगे तब आपको कंटिन्यूअस डिस्ट्रीब्यूशन के ये जो डिस्ट्रीब्यूशन है ना, सपोज यूनिफॉर्म डिस्ट्रीब्यूशन, राइट. अब यहाँ पे डिस्क्रीट डिस्ट्रीब्यूशन कौन कौन से है? The first is the यूनिफॉर्म. ओके, यूनिफॉर्म है. फिर हम बर्नौली डिस्ट्रीब्यूशन देखेंगे. उसके बाद बाइनोमियल डिस्ट्रीब्यूशन. ओके, उसके बाद बाइनोमियल डिस्ट्रीब्यूशन के बाद हम क्या देखेंगे? Now these are all my uniform distribution, Bernoulli distribution, binomial distribution. These are all my finite distribution. Okay, these are all my finite distribution. And then उसके बाद हम देखेंगे there is one distribution which is called as the geometric distribution. Geometric distribution, and then last is the Poisson distribution. Okay, Poisson distribution. And these two are my infinite distribution. That means this distribution, this all distribution which we have studied, these are actually my discrete distribution. I have to just study in this particular chapter these all five distributions which are the discrete distributions. Okay, and in the next semester, second semester, there will be a separate, separate uh, paper will be there for the continuous probability distribution. I think that is the paper second. Okay, so just understand this. These are my finite and infinite. So these are my discrete, right? Now, since this is a discrete, I am using PMF, not PDF. Okay. In the second semester, there will be PDF for all these distributions. But now, this is the right. This is my discrete distribution, so I will just use the PMF. Okay. So that's it. So let's start with the definition. So yes, when my x, suppose I have variable, a random variable capital X, okay, and it is assuming some non-negative values, that is 0, 1 to up to n, then its PMF is given by, okay, it will be said to follow uniform distribution if and only if its PMF is given by. How it is? So my probability of X equals to X, and that is equals to 1 upon n. Very simple PDF. The simple is PDF is what? It is a 1 upon n. And it's take the values, that is n from 0, 1 to up to n. Okay, so that is the PDF equals to 0 otherwise. Okay, just remember this PDF. This is the PDF of the what? Uniform distribution. Okay, now let's see how was the graph of this uniform distribution. So you can draw the graph of uniform distribution like this. Okay, like this you can simply draw. Here there will be the values which are lies between up to n. Okay, so this is 0 up to n. So that specifically it is also called as the rectangular distribution. Okay, rectangular distribution. Right. Now, what are some examples? Suppose, uh, so what are real life situations of the uniform distribution? Okay, so the first example is, suppose I am considering the uppermost faces of a die. Right. Then tell me how many uppermost faces are there in a die? Six faces, right? So I can write, suppose I am considering X as the number of the uppermost faces, right, on a die. Number of uppermost faces on die. Number of uppermost faces on a die. Then then my uniform distribution or the PDF I can write it as, so probability of X equals to X will be what? It is 1 by 6, right? Where my n is from 0 to 6 or 1 to 6. Tell me what will be that? Sorry, not n, right? That will be 1 to 6. Okay, equals to 0 otherwise. So this is the one particular example of the uniform distribution. Okay. Now let's see how to find the mean and variance. Okay, so we are discussing about the mean and variance of the uniform distribution. Okay. So when X is following uniform distribution with parameter n, let's try to find the mean. So expectation of X, just use the definition, right? So what is the definition? It is summation of X into P of X, where I is from 1 to n. So that should be equals to summation of I from 1 to n x into what is P of X? Uniform distribution, right? So that will be 1 upon n. Now 1 upon n is constant, so I will just take it outside to the summation. So 1 upon n into summation of x, I from 1 to n. So this will become 1 upon n into I from 1 to n x. So just substitute the value. So what it will become? 1 plus 2 plus up to plus n, right? So I have to find this summation. Okay. So this is 1 upon n. So always remember this summation is, it is n into n plus 1, okay, divided by 2, right? So this is the summation of all the n values. Okay. Here what will happen then? What will be the second term? Then tell me what is the mean of the uniform distribution? So this will be n plus 1 divided by 2, right? Because this n will get cancelled. Okay, so that is the mean of the uniform distribution. Okay. Now next is the variance. Now variance is already familiar with the term. So what is my formula? The formula is, it is expectation of x square minus expectation of x bracket square. So for that purpose, I have to must find this particular value, right? Expectation of x square. So again, what is the formula of expectation of x square? That will be summation of x square into p of x, right? So this should be equals to p of x, right? Which is 1 upon n. So it is summation of x square into 1 upon n. So this will be 1 upon n into summation of I from 1 to n x square. So this will be 1 upon n. Now what is the meaning of this x square? So that means I have to do the square of every single term. Okay, so that will be 1 square plus 2 square plus 3 square plus up to plus n square. Okay, now I also have the formula for this also, right? If I am finding the square of the every single term, right, in the n term, so that will be 1 upon n, okay, and this should be equals to n into n plus 1 into twice n plus 1, right, divided by 6n, okay. So this is the, if you are finding the square, so this is the square of the all the n terms. That's the reason. What is your expectation of x square then? Yes, this should be here your 1l. Yes, 1n should be get cancelled, right? So this should be n plus 1 into twice n plus 1 divided by 6n. Okay, now try to find variance then. So what will be variance? It is n plus 1 into twice n plus 1 divided by 6n minus expectation of x bracket square. That means what will be that? It will be n plus 1 by 2, right? This was my mean and bracket square. Okay, now just solve this. What will be this term then? Is there some mistake here? 1 upon n. Okay, actually the formula was, it is only n into n plus 1 into 20 n plus 1 divided by 6 only. Okay, not n is there. Yeah, solve this now. So what it will become? This will be n plus, okay, yeah, n square minus 1. Perfect. Perfect. That is the correct answer. Okay. So this is twice n plus 1 divided by 6 minus, do the square of this. So that will be n square plus twice n plus 1 divided by 4. Okay. And if you solve this all, so your answer will be n square minus 1 divided by 12. Okay. So that is my variance of x. Of what? Variance of uniform distribution. So most important, just remember that is my expectation mean of what? Mean of uniform distribution is n plus 1 by 2 and the variance is n square minus 1 by 12. Okay, right? So let's take one example of this. Okay, so let's discuss one example related to the mean and variance of the uniform distribution. Okay, so let x be a discrete random variable with probability mass function, probability of x equals to 1 by 10. So my x is the variable which are taking values 1 to up to 10. Okay, then very simple question, then tell me what will be the expectation of x and what is variance of x. Yes, tell me. Okay, this is the PMF. I have probability mass function. Then tell me what is expectation of x and variance of x. Yes, anyone? First, tell me what is formula we have seen of expectation. Right. Then just substitute the value. What is the value of n from the PMF? Tell me what will be the value of n. Yes, 10. Right. Right. Because our PMF is 1 upon n. Right. And from this we can simply get the value of n is 10. Then what will be expectation then? Just use the formula. Right. So n plus 1 by 2. That means right 11 by. So expectation is n plus 1 by 2. So this will be 11 by 2. Okay. And which will be a 5.5 something. Okay. Now variance also simple. Tell me that the formula you already know, right? Yes. Okay. 8.25. Okay. You have given exact figure 8.25. Yes. So how we are finding that? Again, it is just use the formula n square minus 1 by 12, right? Just substitute the value. So n square is 10 square 100 minus 1 divided by 12. So that will be 99 by 12, right? And if I think you solve this, then you will get this answer, right? So this is how we can find the mean and the variance, right? So that was all about the uniform distribution. Okay. Now next we were going to discuss the our next distribution. Okay, next discrete distribution, right? So these are all the discrete distribution we are discussing. Okay. So next is the Bernoulli's distribution. Okay, let's try to discuss that. The second is Bernoulli's distribution. ओके, तो क्या है बर्नौली डिस्ट्रीब्यूशन? ठीक है। नाउ suppose I am assuming any again I am assuming the same random variable capital X, right? Random variable I am assuming. So it this particular random variable X, this will be a Bernoulli random variable. ये बर्नौली रैंडम वेरिएबल कब होगा? जब ये दो कंडीशन फॉलो करेगा। कौन सी? एक तो दैट मीन्स दिस पर्टिकुलर रैंडम वेरिएबल अगर ये दो सिचुएशन है इसकी, suppose my x of w, suppose I am considering x of w, this will be 1, ये random variable 1 होगा when the outcome of the w, जब w का या random variable का outcome if it is a success, okay, if it is a success, then the x of w will be 1, and if it is a failure, then what will be then? What will be random variable? Right, it will be 0. Okay, yes. So in that such type of the random variable which are giving me two cases, right? Or any trial I am taking, right? When it is giving me these two outcomes, that is success or failure, then such type of the random variable is called as the Bernoulli random variable. Okay, yeah. So what is one? One, when it is one, when outcome of W is, when outcome of W is success, right? When the outcome of W is success. And when it is 0, when the outcome of W is failure, right? When outcome of W is failure. Okay, so that is the Bernoulli. Now try to understand the probability mass function. Now how we can generate the probability mass function from this? Okay, probability mass function. Now here what I am doing, so P is what? So one is what? So that is the outcome of the W, right? When it is success, and 0. So same, I am just considering the, so this is just about the random variable now. But what about the probabilities, right? So here I am considering the probability of success as a P and probability of failure as a Q. Okay, now what is Q? And always remember, this is the probability of success P, probability of failure Q. And the summation of all these will be what? Can you tell me? Yes, this will be 1. Okay, P plus Q equals to 1, right? So that's the reason Q, I can also write it as, this will be my 1 minus P. Probability of failure, I can also write it as 1 minus P, right? Why? Because from this I will get, right? Q equals to 1 minus P. Okay. And from this, I can generate the probability mass function as, so the probability mass function of the Bernoulli distribution can be written as, that is probability of x equals to x should be equals to what? P raised to x. Okay, P raised to x and Q raised to 1 minus x. Since this is the probability of the success, so this will be P raised to x, and probability of failure, so that will be Q raised to 1 minus x. Okay, where x is taking values, what will be the value? Can you tell me? What will be the values of random variable? 0 to, yeah, no, it is only two values, right? 0 and 1, that's it, right? Because this is the Bernoulli distribution, right? That's the reason the values will be only 0 and 1. So this will be equals to 0 otherwise. Okay, so this is the simple PMF which you have to remember. Okay, now With this, I will directly tell you what is the binomial distribution. Okay, what is the binomial distribution? Now here, what we are taking, we are taking only one Bernoulli trial, right? Success or failure. Okay, but when I have the n Bernoulli trials, okay, when I have the n Bernoulli trials, so this is the here what happened. Here there is only one Bernoulli trial is there, one Bernoulli trial. बट व्हेन आई एम कंसीडरिंग द n बर्नौली ट्रायल, जब मेरे पास n बर्नौली ट्रायल होगा तब क्या होगा? देन दैट विल बी माय बाइनोमियल डिस्ट्रीब्यूशन. ओके, सो लेट्स कंसीडर, right? So suppose I have the variable x which have the values 0, 1, 2 up to n. So these are some values of the variable. Okay, then this should be said to follow a binomial distribution. This should be said to follow a binomial distribution with parameter n and p, with parameter n and p. If its PMF is given as probability of x equals to x equals to what? It is ncx p raised to x, okay, p raised to x q raised to n minus x, right? Why? Because here what happening? Here there are n Bernoulli triangles. I am considering the number of the Bernoulli triangles, but here I am just considering the one. So let's take the example. Suppose I am tossing a coin. So in the Bernoulli distribution, what I am doing? I am just tossing a coin one time only. Okay, and in the one time only, I will get success or failure, head or tail. Suppose one is my head, zero is a tail, right? And simple. That will be Bernoulli distribution. What happening in the binomial distribution? I am tossing a coin with certain number of times. Suppose I am considering 5 times. I am tossing a coin 5 times or 6 times, 7 times, whatever the number you can choose. So that value in which I am tossing a coin. Suppose I am considering I am tossing 5 times. So that is my value of n. N equals to 5 if I am tossing it 5 times. Okay, so that's the reason it is called the Bernoulli distribution. If trial is more than greater than 1, okay, if n is greater than 1, if trial is greater than 1, then that will be my binomial distribution. Okay, understand the concept. Yes. Okay. Yeah, so that is the PMF of the binomial distribution. So which is n6 p raised to x q raised to n minus 1. So that should be equal to 0. Okay, and these are taking values uh, 0, 1, 2 up to n. Okay, 0 otherwise. Okay, now first of all, let's consider. Now you already understand the PMF, right? Bernoulli distribution is p raised to x, q raised to 1 minus x, 0 otherwise, right? Now let's try to discuss the mean and the variance of the Bernoulli distribution. Okay, Bernoulli distribution. First, we will cover all things related to the Bernoulli distribution, and then we will see about the binomial distribution. I have to just try to understand you what is the difference between Bernoulli and binomial. Okay, right? Yeah. So the next is the mean and variance, right? So mean is denoted by the expectation of x. You can simply find out by using the formula summation of x into pi. So that should be equals to, yes. What will be this then? Just substitute the value of probability mass function, right? So I from 1 to n x into this is means pi means p of x. Okay, yeah. So what is our probability mass function of the Bernoulli? It is p raised to x q raised to n minus x or 1 minus x, right? 1 minus x. In the Bernoulli, it is 1 minus x because we have only one failure is there, right? So that's the reason we are subtracting from 1. Yeah. So just substitute the value, right, from 1 to n. So what will happen then? Now here also, tell me, is this range is correct? Yes. No, right? What will be that then? What are the random values? Random variables of Bernoulli? 0 and 1, right? So it should be from 0 to 1. Okay. Yeah. So just take the values then. So first will be what? First variable will be, if you are substituting 0 here, here actually the value is x, okay? X from 0 to 1. If substituted 0 here, so this will be 0. If you substitute 1 here, then what will happen? So this will be 1 into p raised to 1 q raised to 1 minus 1, right? 1 minus 1 means what? Q raised to 0, right? So what will be your value then? P into q raised to 0. Q raised to 0 means what? 1, right? So that means my Bernoulli distribution, the mean of the Bernoulli distribution is P. Okay. So expectation of x equals to P. Expectation of x equals to P. Now what about the variance, right? Again, the variance is what? The formula of the variance is expectation of x square minus expectation of x, okay, bracket square. Okay, so just again try to substitute the value. So this will be summation of x square into p of x I from 1 to n, right? This is my expectation of x square minus expectation of x bracket square. Now expectation of x, we already calculated that p bracket square, right? So this will be I from 1 to n x square, okay, x square into p of x. P of x is what? Your probability mass function, right? So that is p raised to x q raised to 1 minus x minus p square is as it is. Again just substitute the value. Yes, it is 0 to 0 to 1. Okay, right. So this is 0 to 1, this is 0 to 1, and just substitute the values again. Now in this quantity only you have to substitute. Okay, p square is constant here. So the first will be 0 and the second will be what? Yes, if we substitute 0 there, so that is 0. Then next will be p. Okay, let's try. I am substituting 1 here. Okay, so 1 p is as it is and q raised to 0, right? That will be p. So that means what I am getting, p minus p square. Okay, wait. काय झालं? कोणतं? Okay, so p minus p square. Now let's take p as a common. So this will be p into 1 minus p. Right, then tell me what will be the answer. This is the variance, right, pq. Because 1 minus p is q, right? You know, p plus q equals to 1. So what is 1 minus p then? This is q, right? So here, so from this, what I'm getting, my mean of the Bernoulli random variable is p, okay, and my variance of the Bernoulli distribution is what? It is a pq, right? Now, same thing I have to calculate for the binomial distribution. Okay, remember that I think for you, you have old, they will ask in the examination only to state mean. Okay, to just state mean and variance. Okay, there is no need to solve this, right? Summation of p raised to x and do the calculations. They will only state, that is, state the mean of this distribution and state the variance of this particular distribution. Okay, so you have to just know that what is mean and variance of that particular distribution. If they are asking for the Bernoulli binomial, right, you have to just state that. Okay, I think so, but still you must prepare, right? Try to prepare all that. Okay, but at least you know what is mean, right, and variance of that particular distributions, right? So let's see about the binomial distribution, mean and variance of the binomial distribution. So just I can use the formula summation of I from 1 to n. Okay, yes, x into probability of x. So this should be equals to summation of I from 1 to n. Sorry, the range is from 0 to n, right? And not I, here I am taking the value x. So x from 1 to 0 to n x into, now here what is the my PMF? It is ncx, p raised to x, q raised to n minus x. Okay, so if we solve this all, right, then you get the expectation of x. This should be equals to np. Okay, expectation of x is np and variance x is, so variance here, how we are finding the variance? So that is expectation of x square minus expectation of x bracket square. Okay, this formula I am using. Yes, you already familiar with the formula. So now here what will happen? Here also we are finding this expectation of x square by using another one formula. Okay, so what is expectation of x square here? Expectation of x square equals to, this is expectation of x into x minus 1. Okay, expectation of x into x minus 1 plus expectation of x. Okay, plus expectation of x. So if you try solve this, right, x into x minus 1, then I will get this as, I solve this, then this will be n into n minus 1 into p square. Okay, that will be the value of this. And expectation of x you already know, right? Np, right? Np. So this will be plus np. So that will be my expectation of x square here. Okay, just try to remember this quantity. What is the expression of x into x minus 1? So that is n into n minus 1 into p square plus np. Right? Now solve this, then what will be expectation of x square? Okay. So what we can do? We directly substitute this expectation of x square in the formula of variance of x. Okay. So let's do that. Suppose my variance of x is what? I know this is my formula, right? I am just substituting the this quantity expectation of x square in this formula. So what will be that then? It is n into n minus 1 into p square plus np minus what is the expectation of x? Np, right? So what will be this then? Expectation of x square, n square p square. Okay, and now just solve this. Yeah, what is first quantity? N square into p, right? Second will be minus n p square plus np minus n square p square. Correct? N square into p, right? Here, what will be the quantities? Is it correct? First quantity. We are multiplying by p square. So here it will be also p square, na? Right or not? Yes, the first will be n square p square. Second will be minus np square, right? Third np. The last will be minus n square p square. Yes, which term will get cancelled then? Right. So this term will get cancelled. Okay. And then this term is remaining. I will take np as a common, right? So if I am taking np as common, what is remaining? 1 minus p. And what is 1 minus p? Q. So what is the formula? So variance of x should be equals to what? npq, right? And what was my expectation? Np. Now understand the difference between the Bernoulli and binomial. Here in the Bernoulli, if you try to solve the expectation, you will get the answer that is equals to p, right? And if you try to solve variance, you will get answer pq. And if you try to solve in the binomial, then you will get the answer that is np, and here it is npq. Why? Because here there are n Bernoulli trials. Okay, so that's the reason mean is np and variance is npq. Here there is only one Bernoulli trial, so answer is P and PQ. Okay, so that is all about the mean and variance. So simply you can simply calculate the standard deviation also, right? So just use the formula. Standard deviation is what? Standard deviation is just a square root of the variance of x. So that will be square root of a NPQ. Same for this also, right? So standard deviation will be what? It will be square root of PQ. Okay. Right. Now, I will just see what is remaining for the Bernoulli distribution. Yes, that's all. I think expectation or variance, that was the only term was there for the Bernoulli distribution. Okay, first let's take some of the real life situation of the binomial distribution. Now, I have already given you, right? What is the real life situation of a binomial distribution? So I can assume the situation, that is yes, I am tossing one coin, right? Only one times tossing a coin. So this will be my one real life situation of the Bernoulli distribution. What will be a result then? It will be true or false. That means I had two outcomes, right? Success or failure. So this will be one situation. What is second consider situation? Suppose I am considering your result, right? So that will be right, considering the student of one student only. So that will be pass or failure. So this will be also one example of Bernoulli distribution. I am considering the customers, right, who are smokers. I am okay. Suppose I am supposing only one particular customer, so that he can be, he can be smoker or non-smoker. So that means in this condition also there is success and success or failure, right? So that is 1 or 0. So these are some my real life situations of the Bernoulli distribution. Now let's consider what are the real life situation of the binomial distribution. Okay, same like this, but what happened here when I am considering the n. Now here I am tossing the coin. Suppose here if I am taking tossing a coin, okay, 5 times, right? So that will be my binomial distribution. Okay. Suppose second considering number of seeds germinated. Okay, germinated in a row of n planted seeds, right? So that will be also one example, real life situation of the binomial distribution. I can also take one example, number of days of rain, number of days of rain during 30 days, during 30 days. Suppose there is a run, then I will denote by 1, no run, then 0. R- Rain by 1, no run by 0. Like this, I will just consider for the 30 days. So that will be my one example of the Bernoulli distribution. Okay. So this is just about the real life examples of the binomial distribution. Okay. Right. So in this, we will just try to solve one example related to the binomial distribution. Okay. So let X is following. X is following binomial distribution with parameter 10 and 0.4. Okay, we have to find first is probability of what happened. We have to find probability of x equals to 4. Second, probability of x greater than equals to 3. Okay, so this I have to find. So how we can find out? Now, first tell me what is the meaning of this? Suppose x is following binomial 10 0.4. That means what? Now understand. What is what is the meaning of this, right? X is following binomial this. So for every single distribution, there are some notations, right, which we am doing. Suppose I have to state the Bernoulli distribution, uniform distribution also, right? I have stated that is X is following uniform n. Okay, for the binomial distribution also, I had stated that X is following Bernoulli n. Sorry, Bernoulli p here. Okay, here the random variable is p because n is not there. So same for the binomial, I am what I am using. It is binomial. x is following binomial NP, right? That is the notation. So from this, I will just simply find out the values. What is given? So suppose x is following binomial. This is my notation. That means from this I can simply find out what are the value of n and p, right? Then tell me what is value of n then? Yes, n is 10 and p is 0.0.4. Right. Now tell me if p is 0.4, then what will be q? Right, 1 minus 0.4, that is 0.6. Okay. So let's try to find out this probability. Probability of x equals to 4. So how we are finding? We are simply using the probability mass function, okay, of this. So what is probability mass function? It is ncx p raised to x q raised to n minus x. I will just simply use this formula. So what will be that then? N, what is the value of n? 10, right? X, which x I have to find? X equals to 4. Substitute x equals to 4. P raised to. Now p, the value of p also I know, right? What is p? 0.4 raised to x 4 q 0.6 raised to n minus x. N is 10 minus x is 4, and you have to just solve this. Okay, this is combination. You can find out this, right? How you can solve? You can directly use your calculator, right? Calc is allowed. Okay. Otherwise, what you can do? You can just use like by using the factorial, right? You already know how to solve the combination problem. 10 factorial divided by 4 factorial into 10 minus 4 factorial, right? That is 6 factorial. And you need to just do this. Okay. So this is how we can find out the probabilities. Okay. Now next is the probability of x greater than equals to 3, right? How to solve this? Suppose I have to find the probability of x greater than equals to 3. X greater than equals to 3. Now greater than equals to 3 means what? Understand now. Suppose I am considering this. Okay. This is my probability curve. You already know, right? PMF is always equals to 1, right? So the area under this curve, it is always equals to 1. PMF equals to 1. Now what happens? Suppose this is the point where I have the point which is 3. Okay. Suppose I am considering, let's consider rather than this, I am considering the line, right? Here 0, 1, 2, 3, minus 1, minus 2, minus 3. I have to find x greater than 30. That means this. I have to just find this, right? This is up to infinite. Okay. So x greater than equals to 3. This will be 1 minus this probability. Okay, 1 minus probability which is less than this. So always remember when there is greater than equals to 3, so that probability is nothing but the 1 minus probability of x less than what? less than 3. Okay, x less than 3. Right? That probability I have to find. Because if I want the probability which is greater than 3, right? This probability I want. So what I will do? I will just subtract all the probability which are less than 3 from 1. Okay, I will just subtract all the probability which is less than 3 from the 1, because I want the probability which is greater than 3, right? Greater than equals to 3, right? So up till 2, I will just subtract that all the probabilities. So that is what I am doing here. Now it is simple again. So 1 minus. Now what is meaning of the probability of x less than 3? So which values I will consider? It will be probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. Okay, and this you already know how to calculate that, right? This is how we are calculated. Similarly, you have to calculate this kind of the probabilities. Okay, so this is how we can solve this probability related problem. Okay, right? So that was all about the Bernoulli's distribution. Now, binomial distribution also we have already discussed mean and variance of the binomial distribution. Sorry, that was the problem of the binomial distribution only, right? Yeah. So this is how we have solved the problem related to the binomial distribution. Now here we have to see recurrence relation. Okay, recurrence relation for the binomial probabilities. Recurrence relation. Recurrence relation for the binomial probabilities. So the recurrence relation. Now, what is the meaning of the recurrence relation? Okay, so recurrence relation is nothing but the to find the relation between the previous probabilities and the yes preceding and the procedure probabilities, right? Current probabilities and the preceding probability, right? That I have to find. Okay, so that is what I am doing. I have to find. I will just find the to find probability of x equals x plus 1. I have to just find the relation between probability of x and probability of x plus 1, right? That I am doing. Okay, now probability of x I already know what it is. It is ncx p raised to x q raised to n minus x. I will what I will do now, I will just try to find probability of x plus 1. Yes, what it will be then. Instead of x, what I am doing, I will just substitute x plus 1. So this will be nc x plus 1 p raised to x plus 1 q raised to n minus x minus 1. Okay, so that is the probability of x plus 1. So after getting this, I will just divide it. I will just take the ratio of these two probabilities. Okay, take ratio. So the ratio, how we can take the, it will be probability of x plus 1 divided by p of x. And just take the two PMFs, right? So first will be nc x plus 1 p raised to x plus 1 q raised to n minus x minus 1 divided by ncx p raised to x q raised to n minus x. Now what will happen here? Yes. Here this particular term, right? P raised to x. P raised to x will get cancelled. Q raised to n minus x. Q raised to n minus x will get cancelled. Right? And only these are the terms which are remaining. Okay. So what is remaining here? Nc x plus 1 divided by, yes, divided by what? Nc x only. P is cancel, right? Now 1 p raised to x cancel, but p raised to 1, right? This power 1 is there. That means 1 p is remaining. Q raised to n minus x, q raised to n minus x cancel, but q raised to minus 1 is still there. So here it is q raised to minus 1. Okay. Now just try to solve this now. So what is this? Nc x plus 1. So that should be what? N factorial divided by, yeah, x plus 1 factorial into what? I'm subtracting the second things, right, from first. So this will be n minus x minus 1 factorial. Okay, divided by, this will be n factorial upon x factorial into n minus x factorial. Multiply by, I can write it as p upon q, right? Q raised to minus 1 means what? 1 upon q, right? So this should be, yes, this is n factorial upon x plus 1 factorial into n minus x minus 1 factorial multiply by, this is again x factorial into n minus x factorial upon n factorial multiply by p by q. Now here what will be get cancelled then? N factorial will be get cancelled. Okay. Now in the next term, just try to solve factorial now. Now here I am just substituting x factorial is as it is. So this is n minus x. Okay, I can write it as n minus x into n minus x minus 1 factorial, right? Yes, because you know that. I can write n factorial as n into n minus 1 factorial. So same I am using here. Okay, divided by, similarly, what will be this? X plus 1 into x factorial. And this is as it is. N minus x minus 1 factorial multiplied by p by q. Yes, so which terms will get cancelled then? X factorial, right? And our other, right? This will be also get cancelled, right? So my answer will be yes. What is the recurrence relation? Probability of x plus 1 upon p of x will be equals to what? It should be n minus x upon x plus 1, right? Equals, sorry, into what? P by q. multiply by P by Q. Okay, and this, write this particular equation, I can also write it as, how I can write it as, probability of x plus 1 equals to n minus x upon x plus 1 into P by Q into what? Probability of x equals to x. And that is the relation between the next probability and the current probability. Okay, so that is the relation between the next probability and the current probability. Okay. Yes, got it. Okay. So that is just about the reference relation of the binomial probabilities. Okay. Next is the fitting of the binomial distribution. Okay, that we will try to discuss separately, because this is fitting of binomial is your one of the practical. Okay, that we will see later. Let's take the additive property of the binomial distribution. Right, so the additive property is simple. So what is the additive property? So it is pretty much simple, right? So what is the concept? When I have two variables x and y, my x is following binomial distribution with n1p, and y is following binomial distribution with parameter n2p, right? Then additive property says that my x plus y will follow binomial distribution with parameter n1 plus n2p. That is called as the additive property of the distribution. But what is the condition when this will happen? When there must be one condition, that is your x and y must be independent. If this x and y are independent, then and only then this additive property holds. Then what will happen? X plus y will follow binomial distribution with n1 plus n2 p. Okay, so that is the additive property, right? So let's take one example related to this additive property. सर एवढं लावून सर मोबाईल काहीच नाही चालणार इथं लावून तिथं लावून इथं मोबाईल लावायचा चालेल माझा मोबाईल 1% दहा किती 10% आत्ता लावलाय रात्री लावला होता का नाही ना रात्री लावल चला ना सर रात्री लगेच लावून द्यायचं Yes, so that was the additive property. So what is additive property? I will tell you. So I am audible, na? Hello. Okay, okay. All right. So when I have two values x and y, then uh, it will hold the additive property when these are the independent. When I have two values x and y, and these are my independent values. X and y are independent, and both are, one is x is binomial n1p and binomial n2p. Then x plus y will be what? Binomial n plus 1, n1 plus n2 p. But again, the condition is what? Probabilities also, probability must be same. Okay. If you are doing, suppose I am considering by x is binomial n1 p1, right? And y is binomial n2 p2, right? Okay, okay, wait, wait. Yes. So if x is binomial n1 p1 and y is binomial n2 n2 p2, right? If this condition is there, then it will be not. Yes. And y will be binomial n2 p2, then it will not follow, right? Then x plus y should not be equals to binomial. It will do n1 plus n2 and p1 plus p2, right? So that is, this is not correct. Okay. So the condition is also, that is p probabilities, my both probabilities must be same. Then only it will follow the, right? It will hold the additive property. Okay, so that is the thing. So let's take one example related to the additive property. Okay. So here I am having two values x and y. Okay. So these are my two independent variables. Okay, x and y are the two independent variables, right? Two independent variables. So, so it will have the binomial distribution with parameter. X is following binomial 5 1 by 2. Okay, and y will follow binomial 8 1 by 2. Right? Two variables I have. What are that? X and y. Okay. The first is the binomial 5 by 1 is the following 5 1 by 2, and y is following binomial 8 by 2. Okay. Now they are asking to find out. First I have to find probability of x plus y by 3 greater than equals to 0.5. Okay. This first I have to find. And the second probability I have to find probability of x equals to 1 given y equals to 3. Okay. Yes. How to find first one then? Yes. I will just use additive property, right? So let's consider z is equals to x plus y. Then tell me what will be this x plus y will follow. Use additive property and tell me what will be x plus y. What is the value of n and what is the value of p? You already know the additive property, right? If x is the binomial n1p, Y is binomial n2 p. Then x plus y is what? Binomial n1 plus n2 p. Then what will be z then? Just anyone. It is 5 1 by 2, 8 1 by 2. Then what will be z? Yes. You can put in the chat box. What will be the answer? Addition of two values, right? Tell me what will be that thing? Yes. It will be 13. Okay. It's just addition of these, right? Two values. So that is 5 plus 8, right? So that is 13 into 1 by. Okay. That is the x plus y. And this you can directly formulate, right? So that is 13 c z 1 by 2 raised to z and 1 by 2 raised to 13 minus z. Now, but what I have to find this probability, right? So the probability of x plus y, right, divided by 3 greater than equals to 0.5. This I have to find. So I can write it as probability of x plus y greater than equals to what? Greater than equals to what? Here it is divided, just multiply by 3, right? 0.5 multiply by 3 and which is 1.5, right? So here I will just use this additive property and then I will get x plus y greater than equals to zero point 0.5. That is what probability of z greater than 1.5. Okay, and here, so this will be 1 minus probability of z greater than 1.5 means what? 1 minus z less than 1.5. Okay, z less than 1.5. So this should be, what will be this then? Z less than 1.5 means 1 minus probability of z equals to 0 plus probability of z equals to 1. Okay, and this I can find out, right? Just using the formulas. So what is that? It is NC0, right? P raised to x, q raised to n minus x. You have to just substitute the values. The value of x you already know, it is 0. The value of n already know, n is what? N is 13 here. Okay, and all the values again p and q also you know. If the value of p is 1 by half, then what will be q? Q will be also 1 by half. Okay, so yeah, just do that and you can find out these probabilities. Okay, now next, yeah, so the next question is you have to find the probability of x equals to 1 given x equals to 3. So how I can do that? Now given probabilities means what? We have seen the definition of the conditional probabilities, right? What is a given b? It is probability of intersection of these two, right? But now in this example, they have given that x and y are independent variables. If x and y are independent variables, then what is the intersection? If a and b are independent events, then what is the probability of a intersection b? It is probability of a into probability of b. So similarly, if these are the intersection, then what will be, sorry, if these are the independent, then what will be intersection? It will be probability of x equals to 1 into probability of x equals to 3 divided by, right, given is x equals to 3, so equals to probability of x equals to 3. Okay, here I think, sorry, it is y, huh? Y equals to 3. Here also y equals to 3. Y equals to 3. So this will be get cancelled, right? Y equals to 3, so, and that is equals to probability of x equals to 1. And this is simple now. This you can simplify now. Just use the formula, right? So that will be 5c1 into p. The value of p is 1 half raised to x means 1 half raised to, yes, n minus 1 just means 5 minus 1. Okay, and so just solve this, so that will be your answer of this particular probability, right? So that was all about the additive property of the, okay, additive property of a binomial distribution. Okay, so the next distribution we have to study, that is the geometric distribution. Okay, geometric distribution. So what is the geometric distribution then? I think this we will try to cover in our today's offline lecture. Okay, only two distribution are remaining now, geometric and Poisson distribution, right? Now up till now what we have did, we have just studied about the finite discrete distribution. Okay, these are my finite discrete. Why it is called as the finite discrete? Because the range of this distribution are finite, right? If you talk about the uniform distribution, what is the range? Uniform distribution, what is the range? X from 0 1 to up to n, right? That was your range. We try to discuss about the Bernoulli distribution. There are only two variables are there, 0 and 1. If we are discussing about the binomial distribution, what is the range? X is from 0 1 to up to n, right? So these are the range. Now here it is finite, right? Okay, this is countably finite numbers. But now from, I think next we have to discuss about the infinite discrete, right? Infinite discrete distribution. Now here your range will be infinite. That is 0 1 to up to so on like this. Okay, infinite range are there. Okay, so that three distribution are geometric distribution and Poisson distribution, right? These are my infinite distribution, right? So that we will discuss in today's offline lecture. Okay. Okay, so just wait. Okay, I will record the attendance.